Hello, let's continue our Sudoku adventure with 12 Drummers Drumming by Matt Tressel. So we have normal 6x6 Sudoku rules. So in every row, column, and 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these drums in the grid. These are counting circles. So if a digit appears in a circle at all, then it appears that many times in the circle. So the example is if I have a 5 anywhere in any of these circles, then 5 of these circles are a 5. So we could do, I don't know. I can't give an example of that. I'm sorry, but here. Anyway, let's not worry about it too much. Then 5 of these circles would be a 5. That would be the example. So if the 5 appears in these drums, then there must be 5 of them that are 5. Exactly 5 of them. No more, no less. If a digit doesn't appear in the drum, then it doesn't appear in the drum. That's fine. Additionally, we have these music notes. They work like white Kropke dots. So they just separate consecutive digits. So if this is a 2, this would be a 3 or a 1. Not all of them are given, meaning I could have 2, 3 here. There's no music note, that's fine. All right, and those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. First thing to do with counting circles is to count them. I'll explain mine in a second. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 counting circles. Now, if you think about it, if a digit appears in a counting circle, it appears that many times in the counting circle. So a digit uses up that many of the circles. So if you think about it, that means that the sum of all the digits that appear in circles is the number of circles. So if a 5 appears in the circle, for example, then that's going to use up 5 of my circles. And so then I would have 7 circles remaining. So basically the digits that I put in the circles must sum, the unique digits I put in the circles must sum to the number of circles. So they sum to 12. We know we need at least 4 distinct digits because of this column here. So we have at least 4 digits adding to 12. Now 5 digits, 1 through 5, would be the minimum, and that already sums to 15. So I know that we have exactly 4 digits that go in the counting circles and 2 that do not. So 4 digits summing to 12. What's the biggest digit I can use? Well, I guess the first question is, can I use 6? I would need a 6 in every box. So let's just go through that. That would make this 6. In this box, that would make this 6. In this box, that would make this 6. And now this couldn't be a 6. We couldn't put a 6 in this box. So we can't actually put 6 in the circles. So 5 is my biggest digit. I know that I must have a 5. Because if I didn't have a 5, then this would be 1, 2, 3, 4. And that adds to 10, not 12. So we need to figure out how we're doing 5 of these. Are we omitting? Let's see. Let's say we used both of these. If we used both of these boxes, then I would take this one or this one. See, it's hard to say. This is a big if, and it's not. See, the problem is I have 6. This column's missing. Okay, that's important. Right, that's another reason I can't put 6. That's actually the reason I can't put 6. Sorry, with this column missing, that means that I only have 5 columns available. So there's going to be a digit missing from. I can't put 6 in there. So each column is going to need a 5. So this column needs a 5. This and this box must use the 5. And so then this has to be the 5. And now that doesn't work, because this box can't have a 5. So this is the box that doesn't have the 5 in it. So it does work. And now, so this is a 5. So we have a 5 in each column. And that was forced. Right? Was that forced? Sorry. The 5 in this column is forced, because there's only one place for it. And now the 5 in this column is forced. Let's actually do it this way. And now the 5 in this column is forced. I can actually fill 5s in these. It's not even speculative. We know we need a 5. And now the 5 is forced to be here. And so this isn't 5. This has to be 5. Okay. Sorry, I did that wrong. So we have 5 5s here. Cool. And then we should be able to place the 6th 5. It goes there. All right. This is consecutive with the 5, so it is 4 or 6. The music note. So now we have 3 digits that sum to 7. The only way for 3 digits to sum to 7 is 1, 2, 4. So all of these are 1, 2, 4. We have 1, 1. So we need 4 4s. And we used up this column. So we need a 4 in this column, this column, this column, and this column. So the 4 in this column has to go here. That's a 4. Now the 4 in this column has to go here. And the 4 in this column's here. And the 4 could be here or here. We don't know which one it is. And then we have a 1 and a 2. Okay, so we need 2 2s. There's only 2 columns left. So this has to be the 2. And then this 1, 2, 4 will just finish off the circles. However, it doesn't matter how they resolve. Okay. So how are we doing the rest of this? 1, 3, and 6 are here. 6 would have to go with 5, so this can't be a 6. 1 would have to go with 2. That would be okay, I think. If 1 went with 2, that would make this a 4. And then 3 could go with 2, but it couldn't go with 4. So this is always a 2. Oh. Because 1 has to go with 2, and 3 could go with 2 or 4, but 4 is gone. So this is always a 2. The rest of this column is 3, 6. Amazing that this is unique. The music notes are doing a lot of work, I bet. This was 5, 4. This would have to be 1. Seems okay. Okay, what else is limited? This, we can't put a 6 here because it'd have to go with 5. So the 6 ends up in one of these two. That makes this a 3 and that a 6, because the 6 is point. The 6 makes that a 4 and a 1. So that's 2 and 4. Nice. Makes that a 3, 6, and 1. Okay, finish this row with a 3. This column, we need a 1 and a 6. Not resolved. In general, this is 1, 3, 6. In general, this is 1, 2, 6. It's got to be this then, right? Yeah, because we need a 3 in the row. So 3 goes on here for sure, and it can't be with 4. So this is a 2, 3 pair, and that's resolved. That's 3, that's 2. That places this 2. So here is a 1, 6 pair. The 1 tells us that's 6 and 1. These 2 digits are a 3, 4 pair. The 4 tells us that's 3, that's 4. That places, that places the 3 here. This is 1 or 6, but it can't be 1, so that's 6, 1, 6, 1, 6. Over here I need 1 and 2. That's 2 and 1. And we're done. All right, neat puzzle, Matt. It's crazy how that resolved like that, but really powerful use of the consecutive dots there. Nice theme as well. I like it. Hope you enjoyed it as well. Let me know how you did. And if you did enjoy it, why don't leave a like, subscribe, and a kind comment below.